So good day, this is the Memory Doctor, and this report is about lipid metabolism. Lipid metabolism. In this report, we have our own table of content, which is we have our first page is about our objectives. Second page is the introduction. Next is the processes, and hopefully last is the glossary, so we can add up some knowledge. So in the objectives, we have our 4 objectives that hopefully we can achieve all of those objectives, and at the end of the report give you some lessons or knowledge that will be useful in your next exam or activities or lessons. So we have our first objectives, which is define lipid mechanism. Second is determine the metabolic pathway. Third, explain the digestion and absorption of lipids. And our last objectives for this report is explain the amount of energy produced during the oxidation of fats. Hopefully we would achieve all these 4 objectives. So in this report, we're going to tackle about different things that is related to lipid metabolism. So there are certain classes of lipids that plays an extremely important role in cellular metabolism because they represent an energy-rich fuel that can be stored in large amount in adipose tissue. So between 1/3 and 1/2 of the calories present in the diet of an average US resident are supplied by lipids. Mostly US citizen people eat more of carbohydrates. So some process involved, and it's mostly lipids that they consume every day, or maybe every day. So furthermore, excess energy derived from carbohydrates and proteins beyond normal daily needs is stored in a lipid molecule. Lipid molecule also adipose tissue, so to be mobilized later and used when needed. So storing some energy or excess energy, stored it inside an adipose tissue so you can use it, or the body can use it whenever it's needed. So lipid metabolism, digestion and absorption of lipids. Most dietary lipids consist of 98% of triglycerols, which is mostly fats and oils. It also has salivary enzyme. Salivary enzyme is present in the mouth that have no effect on lipids, which is water soluble, the salivary enzyme, while the no effect on lipids is water insoluble. So in stomach, most but not all of DAGs change physically to small globules or droplets called chyme, which floats above other material like during digestion. Fats and phospholipids are emulsified and then hydrolyzed into fatty acids and glycerols. So the products are synthesized into glycerides in the intestinal mucosa and flow into the thoracic duct and then into the bloodstream. So you see, there's a lot of process going on in lipid metabolism. But however, such substances are insoluble in water and likewise in the blood. To be transported by the blood, fats and phospholipids form a complex with plasma protein. So such complexes are called lipoprotein. So the mixture of the fats and phospholipids together with the plasma protein created lipoprotein. Abnormalities of lipids metabolism lead to various types of hypolipoproteinemia or hyperlipoproteinemia, or the most common type of abnormality is diabetes, where a deficiency of insulin leads to hypertriglyceridemia. So lipid digestion starts in the stomach. Gastric lipase hydrolyze ester bands, 2 fatty acids, and 1 monoglycerol. About 10% of THG are hydrolyzed. So, high-fat foods stay in the stomach for a longer time, since high-fat meals give you a feeling of being full for a longer time. That's why when we eat heavy meals, we tend to feel full for how many hours? Not until we initiate to take some to go to a comfort room and take out some waste from our body. So chyme enters small intestines and is emulsified with bile salt. So pancreatic lipase hydrolyzes ester bands to form fatty acids and glycerols. Normally, 2 out of 3 fatty acids are hydrolyzed, since fatty acids are monoacylglycerol and bile salts make small droplets, which causes micelles, hydrophobic chain in the interior. Micelles consist of mostly monoacylglycerols and free fatty acids. They are small enough to absorb through intestinal cells, and in the intestinal cells, monoacylglycerols and free fatty acids are repackaged to form a TAGs, or tags, whatever they called it. These new TAGs combine with membrane lipids, which is phospholipids and cholesterol, and lipoproteins to form chylomicrons. So chylomicrons was created due to or with a combination of membrane lipids, phospholipids, and cholesterols together with lipoproteins. So chylomicrons or chylomicrons transport TAGs from internal cell to the bloodstream through the lymphatic system. So from the lymphatic system, the fats flow through the thyroid duct into the bloodstream and then into the liver. So in the liver, here are some actions. Some of the fats are changed to phospholipids. So leaving the liver contains both fats and phospholipids. So those phospholipids, such as sphingomyelin and lecithin, are necessary for the formation of nerve and brain tissues. In general knowledge, the function of blood is to bring oxygen all throughout the body. So lecithins are also involved in the transport of fats to the tissues. So cephalin, another phospholipid, is involved in the normal blood clotting. So you see, from lipid metabolism, we gone to the involvement of blood in creating or making nerves, and then tissues, and then to the blood clotting. So there are actually different processes, or not just one process are involved in making lipid metabolism. So after the cephalin, which is another phospholipid, is involved in the normal blood clotting. From the liver, again, some fat goes to the cell through the bloodstream. So in the bloodstream, TAGs are completely hydrolyzed by lipase enzymes. So fatty acids and glycerols are absorbed by the cell and are either broken down to the acetyl-CoA for energy or repacked to store as lipids. So we have two options when fatty acid and glycerol are absorbed by the cell. So it's either they are stored or they broken down into acetyl-CoA. So the fat in excess of what the cell needs is stored in specialized cells called adipocytes. So we tackle how we said earlier that adipose tissue is where we stored excess energy so that it can used or we can use it whenever we need it. The body can use it whenever it needs. So it turns out that there are specialized cells that also stores excess fats, and that is called adipocytes. So the largest cells in the body, in the adipose, and it is located in the adipose tissue. So located primarily beneath the skin, especially in abdominal region and vital organs. Adipose tissue also serves as a protection against the heat loss and mechanical shock. So it's not just storage for fatty excess or some fat excess or lipid excess that adipose tissue works or function, but it also serve as protection against the heat loss and the mechanical shock. So after that, triglycerol energy reserve fat in the human's body, major source of stored energy. So we all know that our body needs energy. So as much as the body can store, the triglycerol will store enough energy so that whenever the body needs it, we can use it. The body can use it. So energy reserve associated with protein, glycogen, and glucose are small to very small when compared to fat reserves. So at the end of the video, we have a lot to tackle, and in this video, not just the lipid metabolism was discussed, and how the lipid metabolism process, but also its correlated or related processes that take use of some cells that is highly involved in lipid metabolism. So thank you for watching, and I think that's all. Thank you. Bye.